Today we're going to put everything we've done in this unit together, and we're going to be doing what is called solving a right triangle. What that means is you will be told some information about a triangle. For example, you might be told the measure of one of the angles and how long one of the sides is, or you might be told how long two of the sides are. And when you're asked to solve a triangle, you have to tell me how long all three sides are and how big all three angles are. So basically, you're going to figure out everything there is to know about the triangle that you weren't given. So the first thing you need to know is how triangles are labeled in this type of problem. So the angles are generally labeled with capital letters, and the right angle is always labeled with a capital C. The other two angles are capital A and capital B. And the sides are labeled with lowercase a, b, and c. And what you need to know is that side lowercase a is across from angle capital A. So side little a is across from angle big A. Side lowercase b is across from angle big B. And side little c is always the hypotenuse, and that's always across from angle C, which is the right angle. So little a is across from big A, little b is across from big B, little c is the hypotenuse, and that's across from big C, which is the right angle. You need to know this because sometimes they will give you a question that looks like this. You will just be told how big one of the angles is and how long one of the sides is, and you'll be expected to draw the triangle. So you need to know how the pieces are all related to each other. So the first thing you need to look at is what information do you know? So there are two types of problems you might get. The first type is you are told how big one of the angles is and how long one of the sides is. That's what I'm going to be spending this first video on. The second video, I am going to talk about a situation where you know two of the side lengths. So let's look at a bunch of examples where you know the measure of one angle and you know the length of one side. So first, let's talk about the angles. So if you have a triangle, you should know that all three angle measures add to 180 degrees. And the right angle is 90 degrees. So 180 minus 90 is 90. So these two right here, if that one's 90, these two have to add to 90. Because the right angle's 90, so the other two have to add to 90. So to find the missing one, the fastest way of doing that is take the one you know, the 70 degrees, and subtract it from 90 degrees. Now, if you want to go the long way, you could do 90 plus 70 and subtract that from 180. But the shortest way is just subtract the one you know from 90. So the way I would write this is just, in this case, the measure of angle B is 90 degrees minus 70 degrees, which is 20 degrees. All right. The sides, you're going to use SOHCAHTOA. You're going to look at the angle you know, the 70 degrees. Of course, we also know the other angle's 20 degrees, but I generally use the information that the problem gave me to begin with in case I made some silly mistakes subtracting from 90 and got the wrong answer. I like to base my work on the information that the problem gave me. So I'm going to focus on this angle right here. And I am going to set up equations using sine, cosine, or tangent of that angle. So I'm going to label the sides as opposite, adjacent, and hypotenuse. Let's start with A. So if I look at A is opposite that angle, and I need the side that I know the number of. Well, I know this side is 5 over here, and that is right next to the 70 degrees, but it's not the hypotenuse, so that's adjacent. So as I look at SOHCAHTOA, which one has opposite and adjacent? Well, that's tangent. So I'm going to write an equation with tangent of my angle is 70 degrees, and that equals opposite, which was A, over adjacent, that was 5. And then I go ahead and I solve the equation. So A is on top. That means all I have to do is multiply both sides by 5. So I get that A is going to be 5 times the tangent of 70 degrees, which is 13.7 about. Okay, so I know A now. Now I have some options. I know 2 of the sides. I could certainly use Pythagorean theorem if I wanted to find C. Or I could do something similar to what I just did to find C, but this time instead of looking at side A, I'm not going to look at this side anymore. I'm going to focus on this side. So C is the hypotenuse. And I have all 3 sides here. I could use any of them. But like I said before, I like to always use the information that the problem gave me. And that way, if I made a mistake and the 13.7 is wrong, I don't want to get the hypotenuse wrong too. So I'm going to use the 5. So I want to look and use the adjacent and hypotenuse, because I'm trying to figure out hypotenuse. I think I'll use adjacent. So I'm going to use cosine here. So the cosine of my angle was 70 degrees equals adjacent is 5 over hypotenuse is C. C is on bottom, so I need to do 2 steps. I've got to multiply both sides by C. So C times the cosine of 70 degrees equals 5. And then I need to divide both sides by the cosine of 70 degrees. So C is equal to 5 divided by the cosine of 70 degrees. Which is about 14.6. So I now know how long all 3 sides are. I figured out the other angle earlier was 20 degrees. So I have solved this triangle. I know how big all of the angles are. I know how long all of the sides are. So you're going to have to fill in a lot of information to do this type of problem. So again, this is what you do when you are told one of the angles and one of the sides. To get the other angle, subtract the one you know from 90 degrees, and to get the sides, use SOHCAHTOA with the angle you know. So I am going to do 4 examples of this type of problem in this video, and then I will make another video for problems where you know 2 sides. So here's the first example here. We are going to ask you on your homework to fill in the measures of the things you know in this type of format, because it's really hard to grade this type of problem. So let's start by filling in the things we were already told. So I can see that the measure of angle B here is 65 degrees. And the side across from angle B, this would be little b right here. So that's 8.6. And the measure of angle C, that's a right angle, so that's 90 degrees. Now we also want to label the parts that we don't know. We need to label those sides with letters. So across from the right angle is side C. And across from angle A is side A, little a. We need to do that because we can't call everything X. You can't have all of the missing pieces be X. That would get very confusing. You can't have 4 X's in the same problem. They all have to have different variables. So I've filled in the things I know. Now I'm going to go ahead and figure out the missing pieces. And you want to stay organized. So the first thing I'm going to do is figure out the other angle. And that's pretty easy to do. I know that the right angle is 90, so these two have to add up to 90. So the measure of angle A is just going to be 90 degrees minus 65 degrees. And that is 25 degrees. Okay, so the sides I want to label. I could certainly use that 25 degrees I just got, but I am known for making silly arithmetic mistakes. So just in case I made a mistake with my subtraction, I'm going to stick with this 65 degrees right here. I'm going to focus on that angle. So if I focus on that angle, 8.6 is opposite. So I'm going to decide which side to find first. It doesn't matter. You can find A first. You can find C first. I'm unoriginal. I'm going to go in alphabetical order. I'll find A first. So A is right next to the 65, and it is not the hypotenuse, so it would be adjacent. SOHCAHTOA, TOA. Tangent is opposite over adjacent. So I'm going to use tangent to find A. So the tangent of my angle, 65 degrees, equals opposite 8.6 over adjacent A. A is on bottom, so 2 steps, multiply both sides by A. You get A times the tangent of 65 degrees equals 8.6. And then divide both sides by the tangent of 65 degrees. So A is 8.6 divided by the tangent of 65 degrees, which is about 4.0. And I am going to leave the 0.0. That shows that it wasn't exactly 4. It was rounded from something. Okay, now I want C. So I could use the 4.0 if I wanted to, but again, just in case I made a mistake, I'm going to stick with the 8.6. I'm going to use the opposite side still, and C is the hypotenuse. Opposite hypotenuse. So katoa. So sine of 65 equals opposite over hypotenuse. Sine of 65 degrees equals opposite 8.6 over hypotenuse. That's C. C is on bottom, so 2 steps, multiply both sides by C. You get C times the sine of 65 degrees equals 8.6. Divide both sides by the sine of 65 degrees. So C is going to be 8.6 divided by the sine of 65 degrees, which is about 9.5. Now, a couple things to double check. If you're wanting to make sure you didn't make any obvious mistakes, the biggest angle should be across from the longest side. And these are grouped as an angle that's across from a side. So smallest angle here is across from the shortest side, and biggest angle is across from the longest side. So it does look like I haven't made any obvious mistakes. That's not to say that I may not have made a mistake somewhere, but there's nothing that's jumping out at me going, well, that's definitely a mistake there. Okay, let's look at a second example here. Again, first thing I'm going to do is fill in the information that I was given, and then label the sides that aren't labeled. So we were told that the measure of angle B is 55 degrees. C is the right angle, so the measure of angle C is 90 degrees. And this 11 is the hypotenuse. It's across from angle C, so that is little c right there. So the other pieces are unknown. We need to label the other 2 sides. So across from angle A is little a, and across from angle B is little b. The first thing we will solve on this is we're going to figure out how big angle A is. So the measure of angle A, well, the right angle's 90. That leaves 90 degrees for these 2 to add up to. So 90 minus 55 degrees is 35 degrees. You can check, make sure those 3 angles always add to 180. And they do. Decide which of the 2 sides you're going to go for. It doesn't matter which one you're looking at. Again, if you want to use the 35-degree angle, you certainly can. I always just like to focus on the one they gave me in case I made a mistake somehow subtracting. So I'm going to look at the 55-degree angle. I'm going to go for A first. The 11 that I know here is the hypotenuse. And A is right next to the 55 degrees, so A is adjacent. Adjacent hypotenuse, cosine. Cosine of 55 degrees equals adjacent A over hypotenuse, 11. A is on top, so multiply both sides by 11. And you just get that 11 times the cosine of 55 degrees equals A. So that is about 6.3. So I'm going to find B now. So again, I could use the 6.3 if I wanted to. I could use the 35 degrees if I wanted to. I just don't like to use my own answers in case I made a mistake getting them. So I'm going to still use this 55 degrees. B is opposite the 55 degrees. So I'm going to use the 55 degrees, B is opposite to that, and 11 is the hypotenuse. Opposite, hypotenuse, so, sine. So the sine of 55 degrees equals opposite, B, over hypotenuse, 11. Multiply both sides by 11. And you get that 11 times the sine of 55 degrees is B. So B is about 9.0. So once again, if I look at this, the smallest angle is across from the shortest side. The biggest angle is across from the longest side. The angles add up to 180 degrees. So I don't see any obvious mistakes. There could definitely still be mistakes, but nothing that's jumping out at me. Now, there are other choices I could have made. Once I got the first side here, I could have used the Pythagorean theorem with the 11 and the 6.3. If you did that, you may have gotten a slight rounding error because the 6.3 was rounded, but you could have done that. You could have used the 35 degree angle instead of the 55 degree angle. That would have flipped these fractions upside down because it would have switched which side was opposite and which one was adjacent, because you would have been looking at the other angle. There are lots of different ways you can do this. I'm showing you one choice here. Okay. The next type of question that you might get is a question where the triangle is not drawn for you. You have to draw it. And it doesn't matter which way it's rotated, and I'm not going to get out a protractor and measure whether your 72 degree angle is actually a 72 degree angle. That's... You know, it's not really important that it looks perfect, but what does need to be right is your labeling. So I am told that I have a 72 degree angle. So I'm going to draw something that's about 72 degrees. That looks like it's about 72 degrees. And I know it's a right triangle, so I need a right angle there. So here's my right angle. Here's 72 degrees. So the 72 degrees, that's angle A, and the right angle is angle C, and the other angle is angle B. Now I'm also told that side little c, that's the hypotenuse, is 10. So I can go ahead and fill those things in here. And I also know that angle C, the measure of angle C, is 90 degrees. Now I also need to label the other two sides. So across from my 72-degree angle, which is angle A, I have little a. And across from angle B, I have little b. Now if you drew your triangle rotated around, that's totally fine. I don't care which way it's rotated, as long as little a is across from big A, little b is across from big B, little c, which is 10, is across from big C. And the 72 degrees has to be angle A. So it doesn't matter which way it's rotated, you just have to have the numbers in the right place and the letters in the right place. So let's go ahead and figure out the missing pieces here. So I always start with the other angle because it is the easiest. So the right angle's 90, that means these other two have to add to 90 because we need a total of 180. So the measure of angle B is 90 degrees minus 72 degrees, which is 18 degrees. So I've got my angles. Again, I'm going to focus on what I was told. So I was told about this angle, so I'm going to focus on that as I label my sides. I'm going to look for little a first. So little a is opposite that angle, and 10 is the hypotenuse. Opposite and hypotenuse, SOHCAHTOA, so is opposite and hypotenuse. That's sine. The sine of 72 degrees equals opposite, that's A, over hypotenuse, 10. A is on top, that means you just have to multiply both sides by 10. And you get that 10 times the sine of 72 degrees is A. So A is about 9.5. All right, then B is adjacent. So if I still want to use the 10 and I'm trying to find B, I'm dealing with adjacent and hypotenuse. Cosine. Cosine of 72 degrees equals adjacent B over hypotenuse, 10. Multiply both sides by 10. And you get that 10 times the cosine of 72 degrees equals B. So B is about 3.1. So again, shortest side is across from smallest angle. Longest side is across from biggest angle. Angles add up to 180. You could check the Pythagorean theorem, see if that worked. But looking good. All right, last problem of this type where you are told an angle and a side. This time I am told that one of the angles is 20 degrees. That's beautiful. Okay, so I'll put that down here. There's a 20-degree angle, and that's angle B. The 90-degree angle is angle C, and there's angle A. And I'm told that little a is 15. So across from angle A, here's little a, that's 15. Across from angle B is little b, and across from angle C is little c. So filling in what I know the measure of angle B is 20 degrees, the measure of angle C is 90 degrees, and little a is 15. So easiest thing to find first is the other angle. I know that the right angle is 90 degrees, so these other two angles have to add to 90. So the measure of angle A is 90 degrees minus 20 degrees. 70 degrees. All right, I am going to choose to focus on the angle I was given. I'm going to try to find B first. So little b is opposite that angle, and I need to use the 15, which is right next to that angle but isn't the hypotenuse, so it is adjacent. Opposite and adjacent, TOA. Tangent. The tangent of 20 degrees equals opposite B over adjacent 15. Multiply both sides by 15. And you get that 15 times the tangent of 20 degrees equals B. So B is about 5.5. All right, I want C. C is the hypotenuse. So if I want to use the adjacent side, I want to use the 15 still, and I'm trying to find the hypotenuse. Adjacent hypotenuse, that's cosine, ca. Cosine of 20 degrees equals adjacent 15 divided by hypotenuse, C. C is on bottom, two-step problem. Multiply both sides by C. C times the cosine of 20 degrees equals 15. Divide both sides by cosine of 20 degrees. So you get that C is 15 divided by cosine of 20 degrees, which is about 16.0. So, smallest angle is across from shortest side. Biggest angle is across from longest side. Angles add up to 180 degrees. Looks good. So click on the next video to see the other type of problem, which is where they tell you two of the side lengths, but they don't tell you anything about the angles.